How to apply sign convention in Kirchhoff's laws. Imagine you're trying to solve a puzzle where every piece must fit perfectly. That's what applying sign conventions in Kirchhoff's laws feels like. It helps you keep track of currents and voltages so everything adds up correctly. When working with electrical circuits, understanding how to assign signs is key to getting the right answers. It all starts with knowing the two main laws: Kirchhoff's current law and Kirchhoff's voltage law. Kirchhoff's current law says that the total current flowing into a node equals the total current leaving it. To keep things simple, you pick a direction for each current. If the current flows into the node, you assign it a positive sign. If it flows out, you assign it a negative sign. The trick is to stay consistent. If you initially assume a current flows into a node, stick with that assumption throughout your calculations. If the actual current flows the opposite way, your answer will be negative, which shows the true direction is reversed. This way, your sum of currents at the node always equals 0, which matches the law perfectly. Now, for Kirchhoff's voltage law, think of walking around a loop in the circuit. As you move through the loop, you assign signs to voltage rises and drops. When you go from the negative to the positive terminal of a battery or resistor, you consider it a voltage rise and give it a positive sign. Conversely, moving from the positive to the negative terminal is a voltage drop, so you assign it a negative sign. This method keeps your calculations consistent. If you accidentally switch the polarity, the resulting voltage will be negative, indicating the actual polarity is opposite to your assumption. Applying these sign conventions involves a few simple steps. First, identify all the nodes and loops in your circuit. Next, choose a direction for each current, whether you think it flows clockwise or counterclockwise. When writing equations, assign signs to currents based on whether they enter or leave a node. For voltages, pick a traversal direction around each loop and mark voltage rises and drops accordingly. Remember, the key is to be consistent throughout your analysis. When you write the sum of voltages around a loop, it should equal 0, following the law. Solve the equations to find unknown currents and voltages, and you'll see how these sign conventions make everything clear and manageable. In real-world electrical engineering, applying these sign conventions correctly is essential. Whether you're working with direct current circuits or alternating current circuits, the same principles apply. In alternating current circuits, you also consider phase angles, but the basic idea of assigning signs based on direction and polarity remains the same. Proper sign conventions help you troubleshoot circuits, verify your designs, and ensure your calculations are accurate. So remember, when applying Kirchhoff's laws, always assign positive or negative signs based on the direction of current flow and the polarity of voltage sources. Keep your signs consistent, and you'll be able to analyze even complex circuits with confidence. This simple approach makes solving circuit problems straightforward and helps you understand how electrical components work together seamlessly.